So in the last class, we are looking at the division of hydrocarbon. We divided hydrocarbon into three major parts. Though this division is not the major division, but is actually unique in the dimension of what you want to address in our discussion. So you have alkenes, you have the alkenes, and you have the alkynes. Alright, so we shall be taking them one after the other. Now, in naming every carbon or any form of hydrocarbon, it's important that we know certain root words and prefixes. For example, we need to know that hydrocarbons are made up of carbon and hydrogen. So the number of carbon tells us what that name is going to be, in addition with the functional group. For example, if I have one of the ways by which you identify alkenes is just with a single bond, carbon single bond. Identifying alkenes is double bond and alkynes is what? Triple bond. Now, if I have an alkene with one carbon atom, let me say that when the number of carbon is 1, then let me say this is the root name. Okay. So when the number of carbon is 1, the root name is going to be called meth. When the number of carbon is 2, the root name is S. When the number of carbon is 3, the root name is prop. When the number of carbon is 4, the root name is going to be boots. Right? So when the number of carbon is 5, let me take it this way, the root name is going to be pence. When the number of carbon is 6, the root name will be hex. When the number of carbon is 7, the root name will be hept. When the number of carbon is 8, it's going to be oct. When it is 9, it's going to be non. And when it is 10, it's going to be dec. So it's important that we know all this order, and then we can use them to name each of these alkenes, alkynes, which are examples of hydrocarbon, and possibly draw their structures. So I'm going to take some examples here from what you have said. So I want you to put those numbers at the back of your mind. For example, if I have carbon, note also that carbon is tetrahedral. Carbon is what? Tetrahedral. That is, carbon has 4 bonds. So this is very important in getting the structures of carbon and even the molecular formula and so on and so forth. For example, if I'm dealing with a component that has 1 carbon atom, which is an alkene, for example, I have carbon 1, 2, 3. Then I saturate the others with hydrogen. For example, I have something like this. Right? So why did I draw it this way? Carbon, you have said, must have 4 bonds. So and these are the bonds: 1, 2, 3, 4. 4 bonds, right? And then you have saturated it with 4 bonds, and then hydrogen is completed. So this is called CH4. Now the name of this compound, because it is single bond, is going to be called an alkene, and the number of carbon there is just 1. So we are going to write the root word for 1 carbon, meth, and because it has just single bond, so it's going to take the family name of this, so it's going to become methane. So methane is CH4. So if I have 2 carbon atoms, 1, 2, we've said that carbon is tetrahedral, that means it has 4 bonds. So this is just 1. So if I want to complete the number of bonds here, this is going to be 1, 2, 3, 4. 1, 2, 3, 4. So then I can saturate this part with hydrogen. So here I'm going to have this first carbon, CH3. Then this carbon has 3 hydrogens saturated to it. This also has 3 hydrogens saturated to it. So I can write it this way, CH3, CH3. Or I can write it as number of carbon here is 1, 2, 2 carbon atom and 6 hydrogen atom. So this is carbon-carbon single bond also. The root number is going to be S. Why? Because it is having 2 carbon atoms. and then it is single bond, so the parent name is going to be ethane. So this is an ethane. So we can do the same thing with other ones too. For example, I want to write uh, a carbon atom of 5, for example. So it's going to be a pentane if it is for single bond, right? And how do I get to know that? Said 5 carbon atoms single bond. 1, 2, 3, 4, 5. So for every carbon it has to be tetrahedral, 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then I can saturate them with hydrogen, 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 hydrogen. So this is going to be CH3, CH2, 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 CH2. This is the way. Or I count the total number of carbon, C5. Total number of hydrogen there is 12. So this is the pentane. So that is that for alkanes. You can do the same thing for any of the alkanes, given a number of carbon to be definite. So if I consider an alkene group, for example, let's take an alkyl group. We said alkyl used to have double bonds. So if I have something like 1, 2, right? So 1, 2, 3, 4. So this is complete. 1, 2, 3, 4. This is complete. So I can saturate it this way. We all know that carbon is tetrahedral, so it must have 4 bonds. I can't write more than 4 bonds here. Either more than 4 bonds here. So I've made it 4 bonds here. So this is CH2 double bond CH2. Or I can write it as C2H4. So looking at this, the root word here, because it is 2 carbon atoms, is going to be an F. Right? And because it is having double bond, it's an alkene group, so it's going to be ethene. So that's the name of this, ethene. Ethene. So we can try also with another one. Right? Let's look at other ones like maybe 3 carbon atoms. Now if I have 3 carbon atoms, I must have a double bond for alkene. And then 1, 2, 3, 4. That's now 4. That's complete. I don't need to put anything here because carbon is tetrahedral. 1, 2, 3, 4. 1, 2, 3, 4. So I have it this way. Right. So here I'm going to have CH2, double bond CH, then CH3. Right. So here, this compound can also be named C3H6. Right. And this can be called what? Because the number of carbon is 3, that's a prop, and it is a double bond, so that's a propene. So you can see how we come about writing each of the structures. So if I come back to writing it in another form, for example, let me take the number of carbon to be 6. So that's going to be an hexene for double bond. So I have 1, 2, 3, 4, 5, 6. Don't forget, for alkene there must be double bond, so I'll have something like this here. So this will be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we have something like this. So this can be CH2, double bond CH, CH2, 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 and CH3. So this is going to be C6H12. So that's hexene. So lastly, I can take the same principle also for alkynes. So if I'm to do that of alkynes, so that's for triple bond, I'm going to have, for example, the first member. This is the first member. 1, 2, 3, 4. 1, 2, 3, 4. So that's C2H2. So that is ethine, right? So the next member, so that's 3. 1, 2, 3, 4. 1, 2, 3, 4. Then this is 1, 2, 3, 4. So I have it this way. So this is CH, triple bond C, and CH3. So this is 3 carbon and 4 hydrogen atom. So the root name is prop, because it is a triple bond hydrocarbon is going to be called propane. So that's how I do the naming. And lastly, the last example, let me take a pens, that's 5 carbon atom on alkyne group, so that's the pens group. So 1, 2, 3, 4, 5. Let me take the triple bond here. So this is 1, 2, 3, 4. 1, 2, 3, 4. So this is complete. I don't need to put anything up or down. 1, 2, 3, 4. This. So it will be CH triple bond C, CH2, CH2, CH3. So this is called what? You can count the total number. So that's C5, right? H8. So that is what? Time. So we stop here. Then we proceed in our next class.